Okay, let's unpack this. Today, we're diving into something pretty fundamental, really. What draws us to other people?
Hmm.
And more specifically, how do those, sometimes very particular things we look for in a partner, our mate preferences,
Yeah,
how do they actually fit into the whole story of evolution?
it's a classic question, definitely. In evolutionary psychology, well, it's offered some pretty compelling answers over the years.
Right.
The standard thinking generally is that lots of our preferences, these specific traits we find attractive, they evolved because favoring them somehow gave our ancestors an edge.
An edge, like better health, or...
Yeah, better health, maybe more resources, or just, good genes to pass down to the kids.
Right. And you've probably heard the examples, yeah, like
Mm.
preferring a symmetrical face because it signals what? Good development.
Exactly.
Yeah.
Or maybe liking certain body shapes linked to fertility or health signals.
Okay.
The conventional approach often looks at these preferences kind of one by one, building a case for each based on some potential evolutionary benefit.
Okay. So if liking trait X helps you find a better mate, who then helps you or your kids thrive.
Then the preference for X, well, it should become more common over time. That's the basic evolutionary logic applied to attraction, yeah.
But, and this is where it gets really interesting, we've got this fascinating new study we're looking at today. It's by Kaitlyn T. Harper and Brendan P. Zietsch.
Mm-hmm.
And they used computational modeling, basically running these complex simulations to kind of push back on that conventional view, or at least on that view all by itself.
Yeah, their work suggests that, while those traditional explanations, they're plausible for some things, but there might be this hidden evolutionary speed bump, maybe. Or can you consider the whole picture?
The whole messy picture of human mate choice.
Exactly.
So our mission in this deep dive is really to explore that tension. Let's unpack the standard evolutionary ideas about preferences, see what this study's simulations actually reveal about their limitations, and then
look at some really intriguing alternative explanations the authors put forward for why we're attracted to the things we are.
yeah, because the big sort of takeaway seems to be this. We know people have loads of different preferences, right?
Absolutely. All sorts.
But this research suggests it's surprisingly difficult, evolutionarily speaking, for a whole suite of really specific, independent preferences to evolve through the mechanisms we usually talk about.
Right. So if that's the case, how did we end up with such, diverse and particular tastes? That's the question.
Okay, let's dive in. So you mentioned the conventional view examines preferences individually, leading them to an inclusive fitness benefit. Can we just quickly break that down?
Sure. Inclusive fitness. Basically, think of it as anything that helps get your genes into the next generation.
Yeah.
That's the bottom line.
Okay.
And a preference can help with this in, broadly speaking, two main ways: through direct benefit or indirect benefits.
Okay, give us a quick example. What's a direct benefit?
A direct benefit is something the partner provides that helps you or maybe your existing kids right now.
Like,
Maybe your partner is a great provider, brings home food, or offers protection. That improves your survival, your reproductive success directly. Tangible stuff.
got it. Something immediate, helpful to your current situation. And indirect benefits. That's the good genes thing.
That's the one. Indirect benefits are all about the genes. If you prefer a partner with traits signaling high genetic quality, maybe disease resistance, intelligence, whatever, your kids might inherit those genes.
Okay.
Which makes them more likely to survive and reproduce down the line, even if the partner didn't. Say, bring home extra food for you.
So direct is about improving my situation now. Indirect is about giving the kids a better genetic start for their future.
Precisely. And evolutionary psychologists have proposed preferences for many traits evolved one way or the other. You mentioned facial symmetry.
Yeah.
Others include things like certain body proportions, voice pitch, maybe even that specific, 45.5-degree curve in the lower back of women.
Right, the one theorized to help with balance during pregnancy.
Exactly. Each one seems plausible when you look at it alone, linked to health or fertility or some function.
And yeah, when you hear them one by one, it kind of makes intuitive sense. Like, okay, prefer that curve, get healthier babies, preference evolves. Simple. But what's the catch?
Well, the catch, and this is what Harper and Zietsch really dig into, is that human mate choice doesn't happen in isolation like that. We don't pick someone based on one thing.
No way.
It's intensely multivariate. You're not just looking for that back curve. You're also, consciously or unconsciously evaluating faces, height, personality, smarts, resources, humor, values. The list is huge.
Right. And nobody gets their perfect checklist ticked off, do they? You have to make compromises. You always do.
Exactly. And that is the core challenge they highlight. When you're weighing up, say, 10 different traits and making trade-offs,
Uh,
the partner you actually end up with, they're probably not going to be the absolute ideal on any single one of those traits you started out preferring.
yeah, my ideal might be, I don't know, tall, witty, rich, perfect teeth, specific back curve. But my actual partner might be witty with great teeth, but average height and, doing okay financially.
Right. So maybe your preference for height is strong, and yeah, you're more likely to pick someone taller than someone shorter, all else being equal.
But all else isn't equal.
Exactly. When you're factoring in 7 other things simultaneously, that direct link between your preference for height and your partner's actual height gets, well, it gets watered down, diluted.
Okay, I see. And why is that dilution such a big deal for evolution?
Because selection for the preference itself relies on that link being strong. If having a preference for trait X doesn't reliably, consistently lead you to mate with someone who actually has trait X.
So then the fitness benefit tied to trait X doesn't reliably flow back to you or your kids.
Precisely. The evolutionary pressure on the preference just gets weaker and weaker.
Plus, it's not just us choosing, right? It's mutual. Someone has to choose you back.
Good point.
And we often form long-term pairs, which further limits options and forces those compromises. It's messy.
Very messy. And traditional models, perhaps, sometimes simplified things. Maybe they only looked at 1 or 2 preferences, or they assumed a really tight correlation between what you want and what you get.
Okay.
But this new study basically asked, what happens when you simulate this complex, multivariate mutual mate choice thing more realistically, using computers?
Right. So how did they build the simulation? What were the virtual people doing?
So they created these populations of agents, virtual individuals. Each agent had a set of traits up to 10, things like virtual height or virtual facial averageness.
Okay.
And these traits were subject to natural selection. So agents with certain trait values might be more likely to survive. But crucially, the agents also had preferences for up to 10 different traits in their potential mates.
So the preferences were evolving too through sexual selection.
Exactly. And they could control how many traits the agents were considering when choosing a mate.
So they could crank it up. See what happens when they consider just one preference versus 2 versus 5, all the way up to 10.
Precisely. To see how the sheer number of preferences affects how quickly those preferences evolve.
And they tested both direct and indirect benefits, the good genes versus the helps me now stuff.
Yes, absolutely.
Yeah.
They ran scenarios where preferences only gave indirect, good genes benefits, and other scenarios where they gave both direct benefit to the chooser and indirect benefits via offspring.
Okay.
And the agents would check each other out, evaluate based on their preferences, make compromises, form pairs based on mutual interest, simulating mate choice over many, many generations.
Okay, they built a little virtual dating world reflecting all this messiness. So what happened when they hit run? What did the simulation show?
Well, the results were pretty striking. First, as you'd expect, when agents considered more preferences, the correlation between what they ideally wanted on any single trait and what their actual partner had on that trait went down.
Right. Having a longer wish list means you're less likely to get any one item perfectly. Makes sense.
Makes total sense. But the real punchline was how dramatically this weaker correlation affected the rate of evolution. The speed at which those preferences actually evolved over generations.
How so?
They found that as the number of preferences increased, the speed of preference evolution just plummeted. It slowed down significantly.
Whoa. So it's not just that you don't always get what you want in a partner, it's that this difficulty across many traits actually kind of jams up the evolutionary engine for developing those specific preferences in the first place.
That's exactly it. And the slowdown, the impact, was particularly severe for preferences linked only to indirect benefits, the good genes route.
Really? How severe?
In the simulations where agents were juggling 10 preferences, preferences that only offered indirect benefits showed minimal, almost negligible evolution over the simulated time.
Wow. Okay, so the idea that evolution fine-tuned our preference for, say, that exact back curve or a precise level of facial averageness just because it signaled good genes, that seems like a really, really difficult evolutionary path, according to this model, if we're also weighing up lots of other things at the same time.
It really does challenge explanations that rely heavily on indirect selection for a whole bunch of distinct, separate preferences. But there was a key difference, a really important one.
What was that?
When direct benefits were included in the model. So when preferring a trait also gave the chooser an immediate advantage, like better resources or parental care, preference evolution was much more robust. It still happened, even when agents were considering many preferences.
Ah, okay, that's a huge distinction then. It suggests that getting something useful from your partner right now, direct benefits, might be a much stronger evolutionary force shaping specific preferences.
Compared to just hoping they have good genes for the kids down the line.
Yes, it really highlights that evolutionary difficulty, doesn't it? Linking a preference to offspring fitness when that link is constantly being diluted by having to compromise across many traits and the randomness of genetic inheritance itself.
Exactly. That dilution is key.
You mentioned regression to the mean earlier, too. How does that fit in, making indirect benefits even harder?
Right. So regression to the mean. Even if you manage to pick a partner who is like outstanding on a particular trait you prefer, say, they have exceptionally good genes for disease resistance.
Okay.
Their kids aren't guaranteed to be just as exceptional. Offspring traits tend to, well, regress towards the population average. They'll likely be better than average, but probably not as extreme as the parent.
Okay, so the genetic signal gets a bit weaker just through inheritance.
Right. Now, add the multivariate choice problem back in. You pick this partner not just for those amazing disease resistance genes, but also because they were funny and kind and had nice eyes, whatever.
He's compromised.
You compromised across multiple traits. So your preference for disease resistance wasn't the only thing driving your choice. The partner you actually ended up with might not even have been that extreme on disease resistance compared to the absolute best possible, because you traded off for other things.
I see. So the genetic link is already a bit fuzzy because of regression to the mean.
Mm-hmm.
And it gets even fuzzier because your preference for that specific trait wasn't the sole reason you chose that partner in the first place.
Exactly. So the evolutionary pressure on the preference for disease resistance just kind of dissolves when you're trying to select for 10 things at once via this indirect good genes pathway.
But direct benefits don't have that same problem.
Not in the same way. They don't rely on that tricky intergenerational genetic link quite so much. The benefit comes to you directly from the partner's traits or behavior.
Okay.
The link between your preference, your choice, and the immediate benefit you receive is just, well, it's more direct.
Yeah.
It's less susceptible to being washed out by genetics and compromises.
Okay, so if it's really hard for evolution to sculpt this huge library of specific preferences, especially through indirect selection, because we choose based on so many things, but we clearly do have all these preferences, what else could be going on? The author suggests some alternatives, right?
Yes, absolutely. And they're careful to say, this doesn't mean preferences aren't real or weren't shaped by evolution somehow.
Right, it's about the how.
Exactly. The mechanism might be more complicated or maybe different than the standard story we tell for every single preference, especially the good genes ones.
Okay, so what's one alternative they propose?
One possibility is that maybe our preferences aren't for lots of truly independent signals. Maybe they're for correlated signals of quality.
Correlated signals, like
Yeah.
multiple things pointing to the same underlying good quality.
Not like redundant cues, yeah. Maybe several different physical traits all tend to signal the same underlying thing, like overall health, or maybe low genetic mutation load.
So instead of evolving totally separate preferences for, say, clear skin and facial symmetry and maybe energetic movement, maybe evolution just selected for a preference for something broader, like general health or vitality, and all those specific things, clear skin, symmetry, energy, are just different correlated signs of that.
That's the idea. Your brain might be wired to prefer the overall pattern or combination of these signals, or maybe just pick up on any one of them as a cue for that broader quality.
Okay.
This could make it look like we have many specific preferences, even if the underlying evolved preference is actually simpler, more general. Though the authors do note the evidence for really strong correlations between all the supposed signals of quality in humans isn't always crystal clear.
Interesting. Okay, what's another possibility?
Another really compelling idea revolves around learning. Maybe only a few very broad preference dimensions are truly deeply evolved.
Like what kind of dimensions?
Things like generally preferring partners who seem kind and trustworthy, or partners who seem vital and healthy looking, or partners who seem capable and resourceful, the big picture stuff.
The fundamentals.
Exactly.
Yeah.
And then the very specific preferences for individual traits, like preferring a certain hairstyle or a particular fashion sense, or even, a specific body type that's popular right now. Maybe those arise through associative learning. We learn culturally or individually which specific surface-level traits tend to be associated with those broader, more fundamental, evolved dimensions in our particular time and place.
Ah, that makes a lot of sense. Like, okay, maybe there's a deep evolved preference for a resourceful partner, but what resourceful looks like totally depends on your culture, right? In one place, it might be signaled by owning land, in another by having certain skills, in another by wearing certain clothes. You learn the local signals.
Precisely. It builds flexibility and learning on top of a more basic evolutionary foundation. And it helps explain why standards of attractiveness can change across cultures and over time.
Yeah, that fits really well. Okay, and there was a third alternative they mentioned, something more from cognitive psychology.
Yes, this one leans on how our brains just generally process information. The idea is that our brains are constantly building mental models or schemas of what things are typically like.
Right.
What does a typical face look like? A typical body, based on everyone we see around us.
Okay, we form averages in our head.
Right. And there's this well-known psychological effect called the mere exposure effect. We tend to develop a preference for things simply because they're familiar, because we've been exposed to them repeatedly.
So we might prefer average faces, for instance, not because evolution specifically programmed a preference for averageness linked to good genes.
But maybe just because average faces are, by definition, what we see most often. They're the most familiar.
Yeah.
And our brains have this default tendency to like what's familiar.
Huh. And how does that link back to evolution or adaptation?
Well, think about it. Natural selection often tends to push traits towards an adaptive average within a population. Individuals who are too far from the average on some trait might be less healthy or less functional.
Okay, so being average is often adaptive.
Right. So if our brains have this simple cognitive shortcut, prefer what's familiar average, that shortcut will naturally lead us to prefer traits that happen to be adaptive in many cases, like that optimal back curvature maybe, or general facial averageness. They're common because they're functional.
Wow. Okay, so the preference looks like it was specifically selected for its adaptive value, but it might actually be more of an emergent property, a side effect of a general cognitive bias interacting with the fact that adaptive traits are often common traits.
Exactly. It's a totally different way to think about why we might prefer average-looking features.
That's a real shift in perspective.
It is. Now, it's important to say, this probably doesn't explain all preferences. People often prefer traits that are distinctly above average on some dimension, like height in men, for example. So it's likely not just one of these mechanisms.
Right. It's probably a mix of these different processes working together.
Very likely.
Yeah.
Direct benefits driving some preferences, associative learning shaping others based on broad dimensions, maybe cognitive biases influencing our attraction to common features. It's probably a rich tapestry.
Okay, so let's try and pull this together then. The conventional view often looks at specific preferences evolving one by one, often linked to these indirect good genes benefits. But this study's modeling highlights a major challenge. The fact that we choose partners based on many things at once, multivariate choice, severely weakens the link between any single preference and the actual trait in the chosen partner.
Right, and this weakening effect dramatically slows down the evolution of those preferences, especially if they only offer indirect good genes benefits. It makes that evolutionary pathway look quite difficult for a large number of preferences.
Direct benefits, though things that help the chooser immediately, seem to provide a much more robust pathway for preference evolution, even with multivariate choice.
Correct. The link between preference, choice, and benefit is stronger there.
So this suggests we might need to refine how we think about the origins of our many specific preferences. Maybe it's not always a direct evolutionary story for each one.
Exactly. The authors propose we should explore alternatives more deeply, like preferences for clusters of correlated signals, not just independent ones.
Or the idea of learning specific attractions through association with broader, evolved drives, like seeking kindness or vitality.
Or even considering how simple cognitive mechanisms, like preferring the familiar or average, could generate preferences for common and often adaptive traits as a kind of side effect.
And they frame this whole thing not as, debunking the idea that our attractions are shaped by evolution.
Not at all, but more as an exciting chance to build more sophisticated, more realistic models of how human attraction actually works in all its complexity.
It really does make you step back, doesn't it? And think about why you are attracted to the people you are. Given these potential constraints on evolution crafting dozens of independent preferences, especially via that indirect good genes route, what if many of the very specific things we find attractive The particular features, the styles, the nuances are actually more flexible than we thought. Maybe they're learned, or maybe they emerge from simpler cognitive rules rather than being these ancient, hardwired genetic programs for every single little trait.
It's a fascinating thought. How does considering that possibility change how you think about your own personal map of attraction?
Yeah.
Something to mull over.